Welcome to the next session of heat transfer. Today we study the thermal insulation and critical thickness of insulation. A heat insulating material is the one which has a low thermal conductivity. The thermal insulation is provided in the thermal system to reduce the heat losses. Means to reduce the heat transfer rate, we use the thermal insulation. So next thing is the critical thickness of insulation on a cylinder. Consider heat flow from the steel tube of outside radius R1. This is insulated by a layer of insulation so that outer radius its insulation will be R2. Let the temperature of outside of the steel tube, that will be the T1, and K will be the thermal conductivity of the insulation. Atmospheric air flowing around this cylinder which having the temperature T infinity. H will be the heat transfer coefficient, and T2 will be the outside temperature of the insulating material. We draw the resistance equivalent to this circuit, so that will be the T1 to T2 which having the insulating resistance, and T2 to T infinity which having the convective heat resistance. So now we transfer rate from the insulating steel tube. So we first find the insulation resistance, so that will be in log R2 upon R1 upon 2 pi KL, and convective heat transfer will be 1 upon H 2 pi R2 into L. So to find the heat transfer rate, Q equal to T1 minus T infinity in log R2 upon R1 2 pi KL plus 1 upon H 2 pi R2 into L. Now we plot a graph of Q versus R2. From this graph we conclude that as we go on increasing the R2, the heat transfer rate will increase and reaches to the maximum and then decrease. Hence, at critical radius, that is RC, the Q is maximum. To find the RC value, we use R2, for which Q is maximum. dQ upon dr should be equated to 0, or denominator should be minimum. So d by dr, we use denominator equal to 0. By solving, we get R2 equal to K by H equal to RC. We don't require the derivation. We require only this formula K upon H. So this is the critical thickness of insulation for the cylinder. Now we study for the sphere. This having the same derivation, only difference is that R2 is equal to 2K by H. Means here we have K by H and here we have 2K by H. Means only difference is